Hello and welcome to Technology Update. Despite our five senses, not everything is quite what meets the eye. This episode looks to shed some light on devices that give us a glimpse at what's hiding just out of sight. Remember, the Earth was the center of the universe until Copernicus and Galileo came along. Man's origins were unknown before Darwin changed everything. And the notion that there was something smaller than an atom was nearly unthinkable until Ernest Rutherford. Even today, the quest to gaze beneath the surface just goes on and on. Recently, we took a peek through the glass walls of Skolkovo's Hypercube, where many of Russia's up-and-coming innovators had gathered to attend the annual Zvorykin Prize award ceremony. The competition sifted through roughly 1,500 clever ideas, all looking to come home with one of the 5 top honors. Winners were crowned for the top IT project, the leading innovation for helping society, as well as a trio for best idea, project, and production-ready invention. But in addition to the awards ceremony, there was plenty of other innovation-minded activity going on. Previous finalists and runners-up were also invited to show off the latest developments on their path to full-fledged startup land. A few government officials were on hand to get an up-close and personal view of the country's leading young minds. And while the winners may have taken home the glory, one of the top competitors from a past Zvorykin Prize caught our eye. In the time since the competition, these developers have turned their so-called electronic nose into a nascent business. While it doesn't look like much more than a run-of-the-mill piece of carry-on luggage, this ion mobility spectrometer is being taken to the front lines of the fight against hidden dangers. Their Kerber or Cerberus device can help police save lives as well as help stem the flow of dangerous materials. Just a few seconds are enough for the handheld detector to check for explosive, drugs, and any number of other chemicals in the air. In normal laboratory settings like this, professionals have the latest equipment at the tips of their fingers. The only problem is that tech is expensive and majorly bulky. It's simply unrealistic to get such machinery out into the field to test for illicit goods. As a result, law enforcement have traditionally turned not to technology, but to Mother Nature for the best way to keep a leg up on would-be evildoers.
Sniffer dogs have been used for this purpose for a long time now. They're great at explosives or drugs detection, but they have one major disadvantage. A dog is really only able to work a maximum of 30 minutes before needing a rest. They can resume work only after 6 to 8 hours. Also, a dog isn't able to tell you the exact kind of substance it's found. It can only signal that something is there by raising a paw or giving some other sign. But then it's up to the explosives team to figure it out, very often putting their own lives at risk to do so. Also, every dog is different. Some simply might not be in the mood to work. In contrast, our detectors will work exactly the same as all the others.
According to the developers, what sets their super sniffers apart from their competitors is the simplicity of operation and its ability to identify even the smallest traces without expensive accessories like specialized sampling tissues. Their compact detector weighs in at about 3 kilos, and much of that girth comes from the lithium-ion battery pack. Now, the hunt for potentially dangerous particles begins as the incoming molecules are ionized, which is done by way of the corona discharge. In the connected tube, dry air flows in the opposite direction to the traveling ions. Larger ones interact with the airstream more, and thus are slowed down compared to the smaller ions. From here, they diffuse and gravitate toward the collector. By knowing how long certain molecular compounds take to pass a fixed distance in a defined electric field, these spectrometers can identify what's in the air around us. The detectors come preloaded with a database of known compounds. The ones in the system so far have been selected for their usefulness in the field, but both the programmers here and individual users can add new recognizable compounds as needed. While similar handheld spectrometers exist, many of those have one significant drawback.
Traditionally, these devices have relied on radioactive substances to ionize molecules. We started off with that same principle in mind, but then thought we'd better switch from radioactive compounds to something less harmful. And eventually we decided to use the pulsed corona charge for ionization purposes. It is absolutely safe and is capable of detecting any kind of substance. Actually, we didn't invent it, we just made it really compact. So now it's a portable device and added new functionalities to enable operators to use it effectively in the field.
So far, these developers have delivered more than 200 of their Kerber detectors. At the moment, they're undergoing full-blown certification with Russia's Interior Ministry. If and when they get the all clear, orders from the country's biggest security agencies could start rolling in.